This video is on 8.1 Relations and Functions, Part 2. So far, we've learned about what a relation is. It's a pairing of numbers in one set, or the domain or set of possible inputs with the numbers in another set, the range or possible outputs. So here's an example of that. We have the relation of this domain of inputs to this range of outputs, and we call that a relation. We also learned that relations can be represented in a bunch of different ways. They can be put in an input-output table, as an XY table, a set of ordered pairs, or a mapping diagram. Now we're going to start to identify which relations are functions and which are not. Before we do that, though, let's identify a couple of different types of relations. Here's an example of one. The area of a circle depends on its radius. So the radius would be the input, and the area of our circle would be the output. The radius is dependent, or the area is dependent on the radius. Here's another example. Let's say that Turab has agreed to babysit Arrow for Rocket. Now Rocket has agreed to pay Turab $5 for every 1 hour. Okay. Now the amount of money Turab earns babysitting depends on how many hours he babysits Arrow. So let's think about that. What would be our input? Well, our input would be the number of hours. So I could input 0 hours, and my output, or the dollars, would be 0. I could also input 1 hour, and my dollars would be $5. Now for every input that I suggest, there will be exactly 1 output, because it's dependent on how many hours Turab babysits. So let's say Turab babysits 5 hours. Then he would make $25. So in a way, I can call this my independent and my dependent. This is an example of a relation. Another example of a relation might be my age and my height. Age 13, let's say I was 5'3". At age 14, I was 5'4". 15, 5'5", and 16, 17, 18, and so on, I was 5'5", and so on. Okay. My height is dependent on the age, and I know that if someone can say an age, I can give exactly 1 output, or height. So each of these are considered relations. Now, what makes them a function? A relation with a property is that for each input there is exactly one output is what we consider to be a function. So let's see if this is true of Tarab's babysitting. For every input, we can map it to exactly one output. If you look at my age versus my height, at age 13 I was 5'3", at age 14 I was 5'4", at age 15 I was 5'5", at age 16 I was 5'5", age 17 I was 5'5", and at age 18 I was 5'5". So for every input, I have exactly one output. Now you'll notice one of my output has more than one input, but that's all right. I know that if I say the number 17 for age, I'm always going to get the response 5 foot 5 inches. So that's what makes it a function. If I put in the age 18, I'm always only ever going to get 5 foot 5 inches. So that makes it a function. When it's not a function is this kind of example. Let's say that I list my age and Mrs. Fiedler's age. So I'll be in green and Mrs. Fiedler will be in red. Now let's say that at age 13, let's see, what did I say up here? I was 5'3". And Mrs. Fiedler was 5'2". Here I was 5'4". And let's say she was 5'2". Five, oops. 5 foot 5 and 5 foot 3 inches. All right. Now, if I look at my data here and I map it out, I have 13, 14, and 15 as my inputs. And as my outputs, I have 5 foot 2 inches, 5 foot 3 inches is a choice, 5 foot 4 inches is a choice, and 5 foot 5 inches is a choice. Now I can map these, right? 13 can go to 5 foot 3, or it can go to 5 foot 2. 14 can go to 5 foot 4 or 5 foot 2. 15 can go to 5 foot 5 or 5 foot 3. Now you'll notice in this situation when I say an input 13, I don't have exactly one output. My answer or response to my output could be 5'2" or 5'3". This makes this relation no longer a function because I don't have exactly one output for each of my inputs. Each of my inputs has two outputs.